All right, so for our circular motion now, we're still going to use all of our same equations. Okay, so make sure you have your equation sheet out. We're going to look at the force that's happening on this car right now, okay? There's some car that's going around a curve with a radius of 74 meters, so it's a pretty wide bend, but it's traveling around this curve, okay? We're not so concerned with what the curve looks like at this point. What we want to look at is the free body diagram of the car itself, okay? So we know that centripetal force always goes in what direction? Do you remember? Toward the center, exactly. So if our curve is going, let's say like this, centripetal force should always be going toward the center of the circle. So that's our F sub C. Okay. Friction then would always be doing what? Can we think about what friction might be doing? Yes, stopping us from going to the center. So it's going in the opposite direction. So it'll be pulling us back out. Okay, so our frictional force will be going outward. And I didn't draw my vectors to scale very well. All right, so if we want to know how fast this car can go to make it safely around the curve, that must mean that these two forces should be what? They should be equal to each other. They should be equal, okay? So our centripetal force, or our F sub C, will equal our force of friction. Okay? Are we, does that make sense conceptually? That if we want to stay on the road, if we don't want to skid off the road, we need to make sure that those two forces are at least equal or our frictional force is higher. Okay? So we're looking at the maximum speed this car can travel. So as we're pushing the limits here, we want those to be exactly equal. Okay? So now let's think about what our equation is for centripetal force. Force equals mass times centripetal acceleration, right? Okay, were we given an acceleration here in our problem anywhere? No. So we can't use acceleration, so we'll have to do another substitution. Mass times v squared over r. Okay? And all of that equals our centripetal force. Okay. What's our equation for the force of friction?
Fr equals mu k, or mu force of normal?
Yep, normal force. All right, so do we see where this equation right here comes from? On the left side is our centripetal force. On the right side is our force of friction. Those two should be equal to each other based on our free body diagram up here. Okay? Are we clear up to this point? Yeah? All right. So were we even given a speed here? No, because that's what we want to find. We want to solve for velocity. Okay, that's what we're going to be solving for. We have our mass. Do we have a radius?
Yes.
We have our coefficient. And what do we do about the normal force? How do we solve for the normal force? What will the normal force be equal to on our free body diagram over here? Force due to gravity. Okay, so that means our normal force will be m times g. Okay, so we can solve for our normal force separately and then just plug that number in. So we'll take 1250 times 9.8. Okay. I don't have my calculator up here. 12,250. Okay, so that's our normal force. So that'll get plugged into our equation on this left side over here. All right, so now let's just start plugging in numbers to this equation right here. Okay, our mass is 1250. We're solving for v squared. Our radius is 74. Our coefficient of friction is what? 0.58, and our normal force is 12,250. All right, are we clear on the numbers here so far? Any questions? Okay. So let's go ahead and plug in here. My suggestion would be to go ahead and multiply this right side. So take the 0.58 times 12,250. Okay, and tell me what that side equals.
7,105.
Okay, so if you take 0.58 times 12,250, is that what we get? We agree there? Okay. Then on the left side, what would be your suggestion for getting v squared by itself? What would be your process? I don't hear what you're saying.
Multiply it. Find 74 and 1250.
Multiply this out? Okay, you could. What I would probably do is go ahead and divide this 1250 out. I would divide this 1250 just so I can get this whole term right here by itself. Okay, you can do it anyway. So I would take the 7105 divided by 1250.
I got 5.68.
Okay, I'm going to give myself some more room here and move our equation over to the right side. So on the left we have v squared over 74. And that equals, what did you say, 5 point something?
I have 5.68, so I don't know if you want to round it.
No, that's fine. All right, are we clear with this so far? So now we can take our times 74, multiply by 74. Oops, why did I write 75 there? Okay, and we get v squared equals, all right, so then our last step will be to square root each side. 0.32, I'm sorry. Our last step will be to square root both sides, and we get our velocity to equal 20.5, and our units would then be, okay. All right, so for this problem, it says a ball on the end of a string is whirled in a vertical circle. So now we're looking at it a little differently. We're looking at a vertical, something that's moving in a vertical circle instead of a horizontal. Okay, so it's moving vertically like this. Okay, we want to know if the ball has a mass of 1.35 and the string can withstand 17 newtons of tension. What's the maximum speed the ball can be moving at the bottom of the arc? Okay, so the ball is down here in our path. In what direction would the force of tension be going? Yeah, to the center of the circle, right? The tension is in the string, which is our connection to this whole thing here. So our force of tension would be going up. Our force of gravity would then be pulling it down. Okay. Can we all envision what this would look like? Let's go ahead and set up our net force equation here. Okay, if we have F net, and we have two forces here, we're looking vertically, and we'll just take up minus down, right? We're going back to just our forces. We should be pros at this by this point, right? So we'll take force of tension minus force of gravity. Okay. Our F net here, our total force, will be our centripetal force. Okay, so F net will be the same as our centripetal force. So we need to substitute here Fc equals the force of tension minus force of gravity. Okay. Yeah.
I was asking about at the top of the circle. Would you still do Ft minus Fg?
You do Ft plus Fg, because they'd both be going toward the center of the circle, which is the positive direction. All right, so our centripetal force here, we're looking for maximum speed, right? So we need to plug in for our centripetal force equation mass times v squared over r. Okay, because we want to solve for a velocity as speed. Okay, so we need to make sure that we have a v in there. Force of tension was given to us, right? What's our force of tension? 17. And our force due to gravity is going to be what? Well, our force due to gravity is mass times gravity. So we need to take the 1.35 times 9.8. Okay, so we'll take 17 minus 13.23. Okay, and all that equals on the left side are 1.35 mass times v squared over, what's our r? 0.45. All right. So we'll combine our terms on the right. 17 minus 13.23 is 3.77. So that still equals our whole term here on the left. Our next move would probably be to divide by our 1.35. Okay. So if we divide the 3.77 by 1.35, we should get about 2.79. So I'm going to move my equation over here just a little bit. 2.79 equals v squared over 0.45. Okay, are we clear on the math so far here? Rearranging? Okay, so now what's our next step? Exactly, multiply by the 0.45 times 0.45. So we have v squared equals 1.25. Then we need to square root that. And we get our velocity to equal
1.12.
meters per second. All right, are we good? So if I would have asked for the maximum speed at the top of the arc, we would have been looking right here. Our force of tension would have gone toward the middle, and our force of gravity also would have gone toward the middle because it's still pointing down. Okay, so the only thing that would have changed here is that we would have taken plus Fg plus that number, plus that number. Okay, we would have just changed that part of the problem. Okay, we add the force of tension plus the force of gravity since they're both going toward the center of the circle, which is the positive direction. Okay?